So the plan for tonight is to look a little bit into how the new audit hooks thing works. And I must admit that I actually have no clue about this feature at all, apart from sort of reading 2 paragraphs about what it's supposed to do. So there will be a little bit of exploration necessarily going on. And I thought I'd at least scroll through the PEP a little bit. Right, some C stuff. Right. The Python feature is sys.addAuditHook, which is a callable taking a string and a tuple of extra information. And the other Python interface is sys.audit, which allows you to notify all the audit hooks of auditable events. So basically the idea is that if there is strange stuff going on in your execution, you want to be able to catch that using a user-defined audit hook. So let's play with it a little bit. Event, T. Right, add audit hook F. Right, and we immediately see that it gets called because it gets called whenever something is being compiled, right? So, and since we're on a prompt, we compile stuff all the time. So every time we say something here, we get 2 events: an exec event and a compile event. I'm not quite sure what the second what that compile event is about. In any case, that's the idea. The idea is that you can register a callable, an audit hook, and the audit hook is called every time dangerous internal things are happening. And exec is 1, compile is 1. I think ID is 1 because you might get the address of something. Right. So we see that we call built-ins ID here in addition to the exec and the compile events that we saw earlier. I think if you open a file, then I think you get an open event together with the file name and the mode and some extra info. Right. So I think that's the basic infrastructure. There are a few things I don't quite understand. I'm not sure what happens if you have several events. Is it chained or does it replace it? I suspect that, given that it's called add audit hook, I suspect that it's it chains them somehow. Add audit hook G. Right. Now we get second one, right? So if I say ABC now, I get a call to built-ins ID and then afterwards the second one, right? So it chains them in the order of them having been added. Is there a way to clear them? Of course, I can't see the completion because there's too much stuff going on. No, there's only a way to clear them from C, I think. That makes some sense. Right. Okay, so that's the basic idea. And then there's a list somewhere here that shows that for which kind of things CPython calls audit hooks. Right? There's like a couple of pages of audit hooks that exist. And I think it says that, right, it says that this table is, this table is for, this table is for CPython only. So a valid implementation of audit hooks is just having a sys audit hook that does nothing and then just not implementing any of the events. That would be a bit pointless. But that, I mean, from the documentation, I think that that would be a valid thing to do. Right, so looking at the chat, hi Batuhan, good to see you. Batuhan was complaining that my banner is still broken. That's true. I need to get to that and have a generic one, because apparently it's unrealistic for me to touch it every week. And he also says there is no way to clear or replace the audit hooks from pure Python code. You can only add more, right? That makes sense. Does the audit hook, the other thing I don't quite understand is, can the audit hook prevent something from happening? Can it raise? Right. All right. Native hooks added by the C function are called first, followed by hooks added in the current interpreter. Right. Hooks can then log the event, raise an exception to abort the operation, or terminate the process entirely. Right. Let's actually try the exception thing. So leaving import sys. Let's add a. I'm not sure that's a good idea. Let's add an audit hook that says event starks. Oh no, it's a tuple. It's not a starks. And if event equal built-in.id, raise type error, forbidden, otherwise do nothing, sys.add audit hook f, right? And so most things are fine, but if I say, did I misspell that? Built-ins with an s.id, sorry. Right. Right. That makes sense. And of course I can call sys.exit or whatever within the audit hook to say this looks too dangerous. Okay, I think that's kind of the information we need. One thing that I'm probably not going to touch tonight is the fact that there's a C function and that the hooks defined by the C functions are to be called first. I mean, we will eventually probably emulate the C function, but yeah, that's not what I know much about, so let's not do that tonight. Right, this is complicated. When tracing is enabled, Python hooks are only traced if the callable has a can trace member that is set to a true value. Otherwise, trace function will skip the hook. Okay, that's complicated. Yeah, let's also not care about that for now. Right, so let's write our very first test, and it should probably go to sys test uptest audit py. Right, that sounds like a sensible place. Import sys test simple hook. There's one problem. There's one problem is that we would really like to clear the hooks from the test at the end of the test. Because otherwise, over the run of the test file, we will just accumulate more and more hooks. And let's actually check how CPython does that. It runs stuff in a subprocess, right? That makes sense. And then what does it do in the subprocess? Do test basic. How does it work? Right, so this is the thing it runs, and okay, All right, there are special cleanup events that run at the very end of the execution. Right. With test hook as hook. Right. Test hook. This is quite complicated. Yeah, it feels like implementing this feature is somehow almost easier than testing it. Right. So there's an enter that adds an audit hook and a close, and close just prevents. Right. Let's steal this code. This looks useful. And then I also named the file wrong because it's not an app test. It's a regular test. And then I also need the same kind of helper file. No, sorry, nonsense. Okay, let's steal this context manager. Module sys test audit tests.py. Right. Import sys. Let's add the new files. Actually add module sys test audit and right. And I mean, usually I really like to write my own tests, but in this case it's really a little bit on the annoying side, so I'm going to steal them. Right. Okay, with test hook as hook. Right. I would like to pass this. Is there a main here? Right, there is. This thing cannot be imported because it has a dash in the name. But anyway. Right, something like this. And we can start running it in a non-automated fashion by saying bin PyInteractive module sys test audit tests test basic. Right. Okay. Waiting. This is not really faster to wait for than the regular tests, but it might even be worse. I'm not quite sure. Right. While we wait, we should figure out a way to run this from the test runner properly. How do they do it? They have a do test which runs a subprocess. Right. And then what's the difference between do test and run Python? Ah, that's the finalized part. Okay, I'm going to care about that later. So we want something like this here. This basic, it was called this basic. And we need to find the file. What's going on? It's fine. So audit tests.py is os.path.dir_name of file, and then we join. Right. Some infrastructure. That's fine. Self.fail doesn't exist. So we can say assert not p.return code. And here we should say test basic. Right, and this is not quite correct because we need to run so how many levels do I need to go up? The file, in the test folder, in the sys folder, in the module folder. Is that correct? Let's see. And then bin and active.py. Yes, this is very manual. Right. This could work. Maybe. What is this thing doing? Still running? Oh yeah, tonight will not be fun if simply because running the test is even slower than usual. Do all those tests use test hook? Is that the right, test hook does fancy things. It's a bit annoying. I mean, in some way I would really like to write the tests directly and then have a way to get rid of the hooks, but I suspect, I mean, yeah, I know a way. We can have a way to clear the hooks, but clearing the hooks is only supported if we didn't bootstrap to C. And that should not be a problem because if we bootstrap to C, I mean, if we don't bootstrap to C, then nobody's going to use that to run real programs because it's 2,000 times slower. So we can write our tests in peace and don't have to do this very expensive calling out to pyinteractive.py. Yeah, that, I mean, sorry, now I went in the wrong direction for 15 minutes, but I think that will save us a lot of time for the rest of the evening. Right, so let me try that. No, that's wrong. This is the right editor. Module sys test audit. No, app. Right. So we can go back to writing an app test and so we can also write something like this. No, it goes here. So I mean, this will make this will make this evening a lot more pleasant because we don't need to wait for ages. Okay, fine. And then the only thing I want to do here is I want to say testing clear audit hooks. Right. Right. Yes, and as I said, the plan is to not have this built in after translation, or to have it and not do anything, or to have it and always raise an error. I think that's the plan. And then we can have this here. Oops. Right, yes, that makes me happier. Because I think the first test run only now finished, and that was like 7-8 minutes. So that's way too slow. Right. Right. This will just fail in the same way, but we can wait for it. No, we're not waiting for it. We will start working on the implementation. Kill this. Right. So the implementation goes here. So first in the module def, we say something like audit. And then add audit hook. Like this. And then we can go here at the bottom and, yes, there is an audit already. I forgot about that. It had to be there because otherwise the standard library doesn't work, because it's the standard library is calling audit quite a bit. Right, so like this. So now we need a real implementation here, right here, and no, there is no. What does the add audit hook look like? Syntax error. Okay, let's fix it. But let's first look at the right. Add a doc string. And audit hook. And it really just takes a hook. Right, okay, and so where's the syntax error in our test? Line 34, I think. All right. Okay, I suspect the test will fail. We add audit hook and it does nothing, so we hope it fails. What is not completely clear to me, the the audit hook isn't thread local or anything, right? Thread, no, doesn't look like it. Right. Okay, so where does the I wonder where the information is stored about the audit hooks. It's not completely clear to me yet. Right. And I also wonder, I mean, let's actually look at, I mean, one of the first hooks that I want to add is the ID one, simply because it's simple. And I want to check where, hello, it's an operation. Right. I wonder whether, I mean, there should be a space.audit function or something. Like what does the interface look like here? What's the equivalent of the C function? And I think it should be something like space.audit built-ins.id. And what was the, is it still somewhere? No. Here. Doesn't get, I know it. It gets the number. Right. Let's actually, let's look at the implementation of that in CPython. Right. Built-in module. Right. So we call, I mean, we do the computation and then we call the audit hook saying with the number. Okay, fair enough. And we check for the exception, right? That makes sense. So here it will look like this res wres and return. We don't need to check for the exception because the exception is just an RPython exception and the right thing will happen. And now I wonder what the interface should look like. Should it be like this or like this? It's not completely clear to me. I think I'm actually fine just passing a list of wrap things here. Right. Where is the space? Here's the space, right? So somewhere at the bottom, next to warn is not such a bad place. Event and args w. The w at the end means that it's a list of wrap things. So, and then we say something from pypy.module.sys.vm import audit. We call audit self event and args.w. Right. Okay, so now we know how to call it from within the interpreter. We don't have a test for that yet. We need to add one soon, but and now we still don't completely know what we actually want to do here. So we just added another place that calls this, but not really what's happening here. So we need a place to store the we need a place to store the chain of audit hooks. So let's make a chain object hook, and let's think, is it and next equal none, it's a linked list. We just need to think about the order. We said that if the audit hook is added later, it's called later. So we need to add stuff at the end, which I don't like for JIT reasons. Right, but let's, yeah. I'm just doodling code. I'm not completely clear how it should work. Okay, and the place to stick the chain is something called a space cache. It's basically a way to construct singletons for every instance of the object space. We already talked about what the object space is in earlier streams. It's basically an object that has all the Python APIs as methods. And usually a space is a singleton. After translation, there's only ever one space, but during testing, sometimes more than one instance of the space is created. And there's a mechanism called the space cache that makes it possible to construct other singletons that depend on the space. And that's what I'm doing here. So, right. And so basically, I want to have a singleton audit holder but it depends on the space, and so now I do it like this: space.from cache audit holder. And what that code does is if the space already has an audit holder, it returns it, and if it doesn't, then it will make an instance passing space as the argument here. And we should also store the space, I think. For good measure. Right. And then we can say if holder dot hook chain is none, return. I think that's kind of the important part, right? This here, that's the fast path, right? Yeah, in most of the, most executions will not have a chain, right? So we want a fast return if the chain isn't really there. So that's what we achieved here. And then otherwise, if we have a chain, we can call a method on the chain. Hook chain, I don't know, trigger audit events, event args w. Cool, maybe. Right. Yeah, it's still not completely obvious to me yet how the oops. The order is going to be wrong if we do it in the naive way. But okay, we need some code here, and then we can think about how we add a new hook. And for that we get the hook holder, and we say right, if we do this, then it's in the wrong order. Holder. No. What is it called? Hook chain. W hook holder dot right. Then the newest entry of the linked list is the newest added one, and that sounds wrong, but we can just recurse. We can just say if self.next trigger event argsw. That's slightly dangerous, because if somebody adds thousands of audit hooks, then you can get a recursion error exception. Okay. Let's write it like that and think about another approach later. Right, and then so now we triggered all the older hooks, and after we're done with that, we should trigger our own hook, and that should just be space.call function with right, there is a new text event and space.new tuple rxw. Right, and that's very inefficient because now we're creating a new tuple for every hook. So we should instead do that further up somehow, and then just pass those. Right, and right. Yes, that looks somewhat reasonable, maybe. So let's run the test again. I think that has a chance of working. Right. Right. So this, I mean, we get this error because this assert fails, but then the testing clear audit hook also fails because it doesn't exist. So we're not getting the assert failure. Instead, we're getting the exception from the exit method on the context manager. Right. So let's actually run the test without this call, right? Maybe that works. And while we run that, we can think about no, wrong. Where should it go? Interp magic is probably a good place. Right. So, oops. Here. Not completely obvious to me yet how we can detect. Yes, that's a problem. Fixing typos. 466. Wait, what's wrong here? Not enough. Right. This would have gotten me a nicer error message if only I was running my tests on PyPy. But I'm not. Right, okay. Where was I with the magic module? I think there's a way to figure out that we're currently translating stuff. Right. I mean, I'm sure there's one. Okay, let me show you the bad way to do stuff. The bad way to do stuff is the following. Clear. Well, bad. The somewhat less nice way to do stuff works like this. we can say get the singleton again, audit holder. What's it called? Hook chain. Right. So that's the functionality, but now this is dangerous because we can now call it after translation. It's bad. So we should say if, wait, do we have the import? Oops, sorry. Yes. There's this magic function. If we are translated, and that's an RPython function that returns true if we run the code as regular Python code. Returns false if we run the code as regular Python code, but after translation in C, it will return true. And then we can say raise operation error space dot wait. It's a runtime error, I suspect. Well, right, so that's one way to do it. That means that the function is still there after translation, but if you call it, you get a runtime error. That's one way to do it, and the PyPy module reason is quite magic. So I'm not too worried about having this extra function there that does nothing. But I think there's also a proper way to not even have the function, and I think. Right, you can say if space config translating, and then you cannot even add the function. And but let's first make sure that stuff actually works, and then we can care about that. Right, there's another typo, trigger audit events here. We don't have a space. We should pass a space. Right. Here, oops, like this, and let's try again. While we wait, we can do the proper thing about this thing. So instead of declaring it here, which is all the functions that will always be there, there is this other function called setup after space initialization. And we can say if self.space dot what was it, config translating if not this. If we're not building a C-based interpreter, we can say extra interp def what we had, and then after translation, even the function will be gone. Right. That's too long. Like this. Good, maybe. So there's another problem with the tests. Stir object is not callable. Interesting, why? Not clear to me. What's going on here? What does that mean? what are the things we're calling? Ah, yes, we're calling the function, we're calling the event and not the hook. We want to call the hook with the event and the args as arguments and not call the string with the args. Right. Cool. And I can go to the tests and re-enable, where is it? Oops, what's going on? Right. Do this. Cool. Mapic instead of magic. More typos. Magic. Some more waiting. Yeah, we should think a little bit about performance here on several levels. I mean, if we have lots of audit calls, I mean, right now we have one on the built-in function ID, which is not called super often. But if we have lots of calls to space.audit in our interpreter everywhere, we need to be sure that it's not super slow. And we already started with that a little bit. I mean, this function is relatively small, and then there is a fast way out of this function by saying if we don't even have a chain, we just return. So maybe that's not so bad. And then for the JIT, we also need to think a little bit about what the JIT will do. But yeah, I mean, those two considerations I want to still get to a little bit after we have the simple functionality tests passing. Right, the first one passes. Excellent. What is the second test? The second test we need to write is that the order of calling things is the right one. So how does CPython do that? What's the second test they're running? They have two hooks, right? That makes sense. Right, that's complicated. We block adding the hook. I actually just want to have a test that the two hooks work. So basically, I want to have a test that says test two hooks and hook 1 and hook 2, and then if we call a test event, somewhat more. Yeah, now those hooks aren't helping us to figure out in which order they were called. Can we do that somehow? Not easily. Okay, I'm just going to define my own hooks here. Event args l.append event args def 1 g event args l.append to event args, and l is a list, and then we have a sys.audit add audit hook f add audit hook g, and then we say try finally testing audit hooks. Right, and now we say what audit tests one. Let's try with the empty tuple, and it should say assert l-1 should be 2 test empty tuple, and -2 should be the same but with 1. Right, and that should work. Let's run it, and that's a great second one. But indeed, I think the other thing we want is we want to have a, I mean, adding a new hook should definitely be a hook, right? So block hook. Let's follow CPython here. Right. Right. This particularly this will not propagate out part is interesting. Right. I don't like this assert in stuff. Assert in. We can if this should be the empty list, right? We don't manage to install the second hook because the first one raises, and so hook 2 should never see any events. Right, what does our test do? Right, it shows that there's a problem because we didn't even test to the recursive call here. So we pass w events and w args. Right. Cool. Right, those are good tests. And now we need to, the third one, it will fail. The second one that we added that calls, that tests that the 2 hooks work and are called in the right order, that one should work, I expect. Oops, it doesn't. Of course. I'm calling this on self, not on next. Linked lists are too hard. I should probably stop with this linked list nonsense and just have a completely regular list, and we'll do that in like 3 minutes. As soon as the second test passes, let's actually do that. It's much nicer. Yeah, we can do that while we wait for the test. Right, the hook chain will just be a none or a list of events. And then we can say right, def. We can move this here, and then it will just be a loop for right. This should only be called right, chain self.hook chain. This should only be called if it's not none, and then we say for w hook in hook chain space dot call function self.whook w event and w args. Then if we add new hooks at the end, which is the natural place to add if we just have a list, then stuff happens correctly. And then we kill this class. Right here. And here we say, okay, if holder.hookchain is none, then it's just holder.hookchain equal hook, and else. And now I'm going to write some somewhat weird code here, and I'm going to explain why later. I'm not using append, I'm using this code. Right. Yeah, much more natural. Matti says there is something wrong here. Yes, thank you. Hi, good to see you, by the way. Thanks for catching my typos. It's much more efficient if you catch them than if I need to wait for the tests. Right. Yeah, the first two tests pass, which we expect, and the third one fails because we don't even have a sys.add_audit hook event yet that we can use to stop adding new audit hooks. Right. So let's rerun to find the typos in the changed representation. And while we do that, we can start the event here. So here we should say we should trigger an event, right? We should trigger the event sys.add_audit hook, and this can raise, and the exception should be swallowed. So we say audit of space and space. No, it's at the event. So we say like this. What is the argument? Right. The argument to this is probably the audit hook. Let's grab for it. Right. No, there is no argument. Right. That makes sense. I suspect. And then if this catches operation error, and what can it catch? If it catches a runtime error. We do not report errors derived from runtime error. So how does it work? I always need to look this up. Error. There's a method here that you can use to match, right? Right. If e.match space.w runtime error, or rather, if it doesn't match, then we will just raise it. Otherwise, we'll runtime error is ignored, and we don't add the new hook. Right, good. And otherwise, we execute the old code. Right. I think I just fixed that. Okay. Cool. I think this is doing something. Maybe. Really? Really? surprising. Seems nobody has caught an error in this file yet. Yeah, there's a local import here which we can kill now, which we added last week. Waiting. I looked it up, and then I managed not to remember for 2 seconds what the arguments to match are, and it takes a space, of course. Sorry, here. Space. Right. More waiting. While we wait, I can explain why I wrote this code in such a weird way here. So RPython actually has 2 kinds of lists, built-in list types. And they're both written kind of in the same way, but they behave, I mean, they don't really behave differently, but they have different performance characteristics. And what RPython does is it infers whether a list is resizable or not, right? So if we never call any of the, if on some list, for example this one here, we never call any method that makes the list larger, like append or extend, or smaller, like clear or whatever, then we realize that the list is not resizable, and then we can represent it just as an array plus a length field. Whereas if it's resizable, we need an extra indirection. We need a small struct that has a pointer to an array, and we need 2 different lengths, one for the real physical length and one for the the over allocated length, and lots of complications. And so in this case, I want even if we have audit hooks, I want this loop to be fast, and loops over direct arrays are a little bit faster. And I don't really care that that adding a hook is quadratic in the number of hooks added, because I suspect there aren't going to be terribly many of them, and that's why I do it that way. And if you want to make sure there is that indeed RPython inferred things in the right way, you can do the following. You can say, where is it? Seems nobody used it yet. From RPython rlib import debug, and debug has a function called debug.make-sure not resized holder hook chain, right? And this is basically an assertion, a compile time assertion, and the assertion will fail if hook chain is inferred to be resizable, right? And hook chain is now a bad name for that field, because it's really just a list, so we should rename it to hooks w. Right. Like this, and the test pass. Excellent. That's great. Cool. Now we can also put the new text and new tuple calls into the trigger audit event function, like this. Oops. W event equal blah, and w args equal need to fix the like this. Okay, cool. There's an extra space here. Right. That should still pass. Okay, let's actually look at the diff. I think we should commit that. We have a new space method that just calls the function in sys.vm. We added an audit hook to ID, which we should test that. We added a clear audit hooks function that is not callable at translation time, and it's not even there at translation time. There's an extra new line here that we should remove again. Here. There is a add audit hook new function. The audit function was already there, it was just not doing anything. And then there's this file that we don't use anymore. So we should say revert right. And same for this one. That was the failed test attempt. Right, great. And so here's the implementation. We have an audit holder, which takes a space, and then just has a none as a default field set here. And then we have a method here that goes through all the hooks and calls them. And then we have an audit function that gets the audit holder from the cache. And if that hooks field is none, we just return. Otherwise, we trigger the audit events. And add audit hooks produces a sys.audit hook events. If that raises a runtime error, we do nothing. Otherwise, we re-raise the exception. And if we didn't leave via the exception, then or the return, then we add a new thing to the hooks list and initialize the hooks list if it didn't exist before. Yeah, the debug import, Matti says, do we need the debug import? And the reason is we need for this thing here. Yeah, that's, we can discuss this during the next test run. But I think, right, and now I need to add sys test. Right. Right. Let's add a test for the ID audit hook. Just look like this. Yes, right. We can do this. The first event we see should be built-ins dot ID with the ID as the only argument, right? Yeah, what I wanted to say is that I mean, it's kind of, it's pretty weird to do it this way, right? I think arguably the RPython language design is really strange here. It's really strange to have these two lists like types, one resizable, one not, and they both look like Python lists. What we should have done instead is we should have just defined our own type somewhere in the RPython R library, and that really says I'm a non-resizable list, and then if you write a list that it really behaves like a Python list and is resizable, that in my opinion that would have been a much clearer design than always having to sort of keep in your head the lists that you intend to be not resizable and the lists that you intend to be resizable, and then have these weird debug calls to do that. And I always kind of want to go back and implement it that way, but it would be a fairly annoying refactoring, and so that's why we never do. But I think sort of from a programmer experience perspective, this was a mistake, and it's one of the. I mean, it's not as big as a mistake as not having separate compilation, which we discussed last week, but I think it's one of the smaller mistakes in our language design. Cool, our tests pass. Let's commit them. Right. Batuhan says that it's confusing, and yes, it absolutely is confusing. Okay, let me think. Actually, I want to look at the tests of CPython and want to figure out what kind of hooks do they test here. So sys audit hook. What does that mean? That's the weird. We won't have those. I mean, PyPy's shutdown works very differently than CPython's shutdown. So we're not going to test this stuff. Right. What else? Pickle. So, right. Pickle produces lots of events, but I suspect that it just does it here, right? And we don't need to implement that because it's already done in the pure Python implementation, and we only have the pure Python implementation of pickle. Right, what else is there? Object.setUtter. Let's do that for the fun of it. And then I don't really want to do open and stuff like that. Can trace. I also really don't want to do the trace events for tonight. Right. So let's do setUtter. So Matti is saying something. Do I want to deal with the sys.flag? Yes, I think I do. Is that implemented? What is io.opencode? This idea is rejected. I think it wasn't implemented. Right. There's nothing about sys.flags here, right? Yeah, I mean, I admit that I didn't read the PEP, so right. Okay. So open code is something else we maybe need to do. Let's keep that on the stack. But the other thing I want to do is setUtter. So what is object? When is object.setUtter called? Yeah, Matti says he didn't read it either, but he read it more than me. Oh wow, that's annoying. Okay, I take that back. I definitely do not want to add to do one, two, 3, 4, 5, 6. There are 6 call sites for object.setUtter. Why are there so many? Right, there's one in set code and set defaults. Yeah, I'm not, I mean, reading this, I'm not really incredibly convinced by the security model of audit hooks, because if you forget, like if you forget to add somewhere in the interpreter the right call to sys audit, then you have a pretty bad hole that you can't. That is not really, I mean, by constructions there can be holes, and that feels a little bit wrong. So maybe let's not think about the general case of setUtter. Let's just do it in the object base class. So what does the test look like? Right. This is caught because this is a dict wrapper. I'm a bit confused. Okay, let me play with this in the terminal. So if we have a class and we add something to it, I thought we would catch that. Isn't this what the test is doing? Or is it really, no, it's name changes, changing the basis, and changing, what is attribute replacement? Does it, no. Okay. Right, this is not what I thought this event is not what I thought it was. I thought it was just a very general way to find setting attributes on objects, but it's really just sort of for dangerous objects, for dangerous attributes, whatever. I mean, however that works. I'm not quite sure what case this here catches, and why I don't really see this case. Right. Right, so that's not what? All right. Can't do that for other reasons. Fair enough. Yeah. Okay. So I'm going to stop this. This looks complicated again. I thought it was a simple, easy thing to add. there's input, code new, compile. Yeah, they all sound annoying. I want a simple one. Exec. Right. Lots of them. Who calls the import one? I wonder where that code actually is. Right. I kind of, yeah, I was wondering whether it was nicely done in the pure Python implementation of the import functionality, but it seems not. It seems there it's redone in the C code. Right. Lots of them. I'm going to stop and not do more of them. What I want to do instead is I want to think about before I add a couple of more. I want to think about the performance implications some more. Wait, I want to go here. So as we discussed, this function is relatively fast if we do not have this thing set. The from cache call gets compiled to nothing. It just gets compiled to, in C it's really just a reference to a static object, right? So that's really just, we really just have the reference to the singleton that we ultimately construct. And then we read the hooks field and return if hooks is not, is null, like is none. And if it's not none, then we call this method. So that's fine. But we will do that in lots of places, right? So for example, if we do ID, then suddenly we do all this extra stuff. So what I want to do is I want to sort of think a little bit about, we have this kind of fast path pattern here. The fast path is returning, and then this one is the slow path, and the slow path is in this function here. And so what I want to do is that on the C level, I kind of want to inline this function into its caller and ultimately inline it completely here, right? Because otherwise the ID function, otherwise the ID function is getting more expensive, or because of all the call overhead. And that, I mean, inlining the audit function into ID should happen automatically because the audit function is relatively small. But what I absolutely want to prevent is, I want to prevent from this function being inlined, right? Because that's the slow path, and that doesn't need to be inline. Object model. I think it's spelled that. Right. Right. So that's one performance consideration here, that we never want to inline this function here because that way this one remains small enough that we can maybe inline it strategically into various places. But I'm not going to force the inlining of this, but I definitely want to prevent this one from being inlined on the C level. I mean, the C compiler might still inline it, but it probably will not because this function looks pretty large. So that's one question. The other question is, what will the JIT do, right? Let's say we're really running in audited mode, and then what does it mean for the JIT performance, right? And what it kind of means is that we want to inline on the JIT level the call to all these hooks, right? And to do that, we need to do some things. What we need to do is we need to tell the JIT that it's safe to unroll this loop here, because the number of hooks should not change often. So we can say at jit.unroll safe. Yep, we imported it. And then the other thing we can do is we can add a really strange annotation here that is called, it's not really an immutable field, right? But we have something that's called, I mean, this would be wrong, right? Because down here we do mutate the field. When we add a new hook, we do mutate the field. So by itself, this annotation is not correct. By itself, this annotation of saying the hooks field is immutable is wrong. But we can say it's kind of immutable. We don't expect there to be changes often, and that's what this question mark means. We saw it in the logs JIT video. It means it's a quasi-immutable field, and what that means is that when the field is mutated, we will throw out all the code that depends on the value of that field, and that makes sense. So if we add a new audit hook, then we can throw out all the code that depends on, that calls audit hooks basically. And we can do one better. We can say that this field is quasi-immutable, so we expect it to change slowly, but it contains a list, and the list itself, like the content of the list, doesn't change. I mean, if we want to change the content of the list, we replace it by another list. And that's what this slightly scary looking annotation means. And it will produce good code in the presence of audit hooks. I mean, I suspect that if you add audit hooks, you should kind of not expect your code to have absolutely fantastic performance. I think that's what you should kind of expect if you use this feature. But we can still sort of ask the JIT to try to produce somewhat reasonable code for it. Right, and we should actually add JIT tests for this feature now, right? We can't easily, because to do that we would have to translate the binary to C, which takes like over an hour, and I want to only stream for maybe half an hour more, so we don't have time for that. But it's on my mental to-do list to the next time I translate a 3.8 binary to check the code that the JIT generates for in the presence of hooks, and check that it looks kind of reasonable. Right. Let's commit that. What does Matti say? Matti says, once a developer has added audit hooks, they have explicitly chosen to trade performance for functionality. Performance impact with hooks added are not of interest here, since this is opt-in functionality. Yeah, that's reasonable. But on the other hand, PyPy has a tendency to care too much about performance, and I mean, I'm not going to do much more than add these two annotations, but I think doing that is reasonable. Right. Okay, so somebody please pick one more hook that you want me to do. An easy one, please. We can definitely do built-ins input. That makes sense. That shouldn't be too hard. And input calls the hooks twice, it seems. And I suspect there is probably not really a test here, is there? No. Okay. So we're not going to add a test either. Right. let's start with this one. So there's built-ins.input, and that gets the argument to input, and then there is input/result with the thing that the user typed. Okay, we can do that. Is input in here? Nope. Input. Ah, very cool. What was it? App.io. Module built-ins app.io. Right. We have sys imported. Great. And we say that's a pity. There are several ways that we call that. Okay, let's start. Here. This is .audit built-ins .input, comma prompt, and where are the returns? Here's a return, and there's a return. Right. We can here's sys.audit built-ins .input/result, and then we pass the result, return result, and down here we do the same, res and res equal. Right. Cool. Does that look good? Are there tests for input at all? If in PyPy. There are. Very good. Should at least test that the existing tests still pass. Right, cool. But one asks, what happened to the software transactional memory stuff with PyPy? That's a great question. Yeah, Matti says we've given up, and that is true. Yay, recursive streaming. That's fantastic. If you're interested, there are two sources. One of them is the blog post that Matti just linked to. I can open that for the people on YouTube. But there was also a paper. So there was also a kind of wrap-up paper about this question. And that was done by, who is that from? Maszek. Let me think. How can I find the paper? Seems the name is too common or something. I will find the paper and tweet it. Yes. Yeah, it's this one, I suspect. Oh Or maybe that's his PhD thesis. Yeah, that's his PhD thesis, which is probably great. But then the last paper is this one, I think. And we cannot get at it. Can we? No, we can. Right. Yeah, I think this I mean, if you're interested in what happened to STM, which is software transactional memory, this is the paper to read. It's from 2019. I think it's a pretty good wrap up about the whole effort. Right. Okay. It's good that we run the tests because there is a typo. Where is the typo? Right, like this. Okay, so Matti says he would like me to do compile, exec, or eval. Those should be doable. Maybe. And they are in here. So built-in. Compiling. Right. Right. Matti says we should link the paper. Yes, that's a great idea. Right. Let's start with eval. Wait, where's the table? There's no eval, there's just exec. And it's exec of a code object. That sounds hard again. Sorry, as you can hear, I'm a bit on the lazy side this evening. So this is the eval built-in. In the case where we run, where the argument to eval is a code object, and the same is true about exec, right? So here is the eval, and what we want to audit is basically this case. If we have if we eval a code object, we want to have an audit hook here. The same for exec. Do we do that for? Where's the audit call? Oops. Or a code object, right? So we want to do the cases where we explicitly pass a code object either to eval or exec. And it should look like this. What's the argument? It's the code object. So we want to do, oops, what's going on with my editor again? Here. Would help if I wouldn't just press random keys. Space.audit exec, comma, wproc. Right. Here, and then exec where's the version with the code? It's an AST. Do we even implement that feature? We check the flags. Ah, that's compile, that's not exec. Sorry. I'm a bit confused. Why does, I mean, there's several things we can do here. One thing I want to do is I want to add a doc string. So right. Is that really what we do here? Yeah, this is very strange. Why is there a special exec function on the frame object? Okay, I'm not really getting less confused. Okay, one after the other. Let's add a test for the eval thing. So what we learned maybe is that if we have a function that like this, let's try it on the console. So import sys def event args sys dot hi Tobias, good to see you. Add audit hook f. So if we now say eval 1, this will get us the exec and compile and blah 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 event that come from the interactive terminal, but we will not. Is that different from saying compile? Can I do this? No, I cannot. That's not what I mean. If I have a return 1 and 1.code, can I execute this? Well, right. Now I get two calls. Right, I get this call here, and this call is running this line, and then I get this call, and this call is about evaluating a code object by passing it to eval, and that's what I want to test. Right, so with test hook as hook, and here I should say assert hook.scene equal exec, comma, red1.code. I think that's the test that I want to pass. And that should not pass yet because we don't call that hook. Okay, good. Now let's think. no, we actually added that here. So maybe it just works. So now the thing that I do not get yet is what this here does. And I think in order to figure that out, I want to put a PDB here and write a test and then see how we end up there. Exec, and let's just say exec print 1. Right. Okay, that passed. Great. So there's this is the one that we were looking at. Is it a method on the space? No. It's here, right? Okay. PyOpcode. What's the test doing? Right. Okay. Right. Okay. Good. Now at least I know where the function is. Exec. No, wait. PyOpcode. It's here. It even has a nice docstring. But the one problem is that one thing that I want to fix is that in PyPy this doesn't have a docstring. So let's fix that. Help exec. Right. So right, and the actual action is here. And I don't really get it. I don't really get why it's done that way. Why it's done as a method and not the implementation isn't just in the build-ins module. But we can implement the audit hook just fine by saying space.audit exec wproc. That should work, and that we need to adapt the test for that. Basically doing the same thing. Exec, right. Let's try. Nope. Matti says. Yes, Matti says that adding audit hooks is a great first task for people that are curious about contributing to PyPy. It's that's a fantastic idea. I should definitely do that. I'm not even sure I mean, maybe having to watch this video first is too much work, but maybe we can have something very low key by pointing to the commit that I'm about to make or something. Yeah, I don't really care about this part. But definitely, it's writing audit hooks is definitely a really good way to get started. And if you're interested, then yeah, I'm happy to help you. Right. it's also a fun fun way to get to know a little bit more of the code base, because the table sends you to various places, and then you can investigate where stuff is implemented. And, cool. Let's look at the commit. So we added audit hooks for exec of code objects in the exec function. We added a built-in audit hook, an untested one, and we added another exec call in the eval function, and then we added the docstring and tests for the eval and the exec hooks. Right. Right. But one says that LibreOffice does a similar thing where they want to fix one of many. Several similar things. They just fix one of them and then add interested parties to fix the other ones by pointing at the initial commit, which sounds like a great idea. So let's see, what did we do? Right. Okay, I'm pushing. What's going on? Right. Ensure pip bootstrap. Very cool. A few of them just work. A number of them are from pure Python, and so we don't have a problem with them. But a number of them don't work, obviously. Okay, unless there are any pressing questions in the chat, I think I'm going to call it a night. That was fun. That's a neat little feature. I'm kind of curious. Did anybody hear any actual users of the audit hooks? I didn't really read anything about that. I would be quite interested in knowing any people that actually use the feature. Yeah. In any case, if you wanna contribute, and this is definitely a nice way to get started. You can pick one of the audit hooks in the table here, and probably not the ones that start with CPython, and then try to figure out where in the code it should be called, and write a test for it, and then add it. And if you're interested in that, then hit me up either on Twitter or on IRC or wherever, and I'm definitely happy to advise you and point out how stuff works. It should be a relatively low-key way to try this out. Right, and if there are no other questions, thanks everybody again for hanging out. Okay, Matti is saying something. Right, Matti says that he suspects there won't be any great experience reports about users, because it's used in big corporations that don't tell anybody about it, or web server deployments. Yeah, that makes sense. Maybe maybe people can tell us in secret or something. Anyway, thanks everybody for hanging out again, and see you all everywhere else on the internet. And yeah, bye. Oh, Batran found something. So what is this? Python. Cool. Various things. Yeah, I also saw that you can use the audit hooks together with dtrace, which I find quite interesting. So apparently you can say that all the audit hooks are RD trace events, which is quite cool. Okay, so thanks everybody. Bye. See you next Saturday or whenever, or online or something.